Hi everyone, in this video I am going to teach you how to find the range of functions, specifically add degree polynomial function, squared function, quadratic function, and absolute value function. Now before I give you the examples, I have a lot here. How do we define range? So what is that? So the range is basically the set of all resulting values. So these are the y values. Now graphically speaking, it's easy to actually find the range of a function. All we need to do is to look at the lowest end of the graph. You start with that up to the highest end of the graph. Okay, so focus on the graph and the y-axis. All right, let me show you now the examples. Okay, so let's start with an odd degree polynomial function. Okay, that's x raised to 3. 3 is odd. Okay, so graphically speaking, this is the representation of that. All right, so how do we find the function of an odd degree polynomial function? Now, it's easy. If we graph an odd degree polynomial function, it will always be like this. Like the left is like this, or sometimes it's actually up there, but you will always have a graph that is going towards negative infinity, and the other part of the graph is going to positive infinity. So, which means that the range of a polynomial function, an odd degree polynomial function, starts with negative infinity to positive infinity. All right, or all real numbers. So focus on the y, look at the graph, look at the lowest end of the graph. So that's negative infinity, and then the highest end of the graph is also infinity, and that's positive infinity with respect to the y values. All right, let's go to the next one. Okay, so here we have a square root function. Let me just show you the graphical representation of this one. So lowest part of the graph is this, and the y value of that is 0. The highest point, now this seems like it's going to the right, which is actually true, it's going to the right, but the focus should be, is it going where? Up. That is correct. And that's infinite, or it's going up indefinitely or infinitely, which means that every time you see a square root function like this, and take note should be positive, you will always have a range that starts with 0 to positive infinity. Always, if it's square root of whatever. Okay? Next. Alright, so here we have negative. I need to emphasize that. And the graphical representation of that is this. So it starts here. Okay, again, that extends indefinitely. So you will start with negative infinity up to, what is that? Right, that's 0. So every time you encounter a square root function like this, and the question is what's the range, you will start with negative infinity up to positive infinity. Let me just compare that to this one, to the previous example rather. So if it's positive square root of a linear expression, you will start with 0 to positive infinity. And if it's negative, you start with negative infinity to 0. Now what if it's quadratic function? Now this is in vertex form. It's easy to find the range of this one. Let me just explain this using the graphical representation. And by the way, this is positive, so the parabola opens upward. This in vertex form, right? So what's the lowest portion of the graph? It's this one. And the y value of that is number 2, which is your k. And going up, it extends infinitely, so which means that the range of a quadratic function, given that it is in vertex form, you will always start with k up to positive infinity. So the k here is 2. There you go. Up to positive infinity, that's the range. Okay? Now what if the graph opens downward? No, what if there is no k? So if there is no k, actually there is a k here. So that k is equal to 0, right? So which means, and this is positive, so the range starts with 0 to positive infinity, right? And this is the graphical representation of that. Now, what if it's negative, like this one? So obviously this one opens downward. It starts with negative infinity up to what? So what's k? This is not in vertex form. What are we going to do? Well, there's a way to that. So the first thing we need to do is to find h. So h is negative b over 2a. This is negative 4 over 2 times negative 1. That's negative 4 over negative 2, which is positive 2. That's your h. And then after that, we will do f of 2 to find k. So 2 squared plus 4 times 2 plus 2. So 2 squared is 4. There's a negative sign. 8 plus 2 is 10. So our k is 6. So there you go. This one opens downward. So we will start with negative infinity up to that number k, which is 6. That's the range. Okay? Let's go to the next one. Okay, so this one opens upward. What's that k right there? Right, so this is k up to positive infinity. Just like what we did in the previous example, let's solve for h first. So b is negative 6, so negative 6 over 2 times 1. Okay, so this is 6 over 2, which is equal to 3. So if h is 3, what is k? So this is 3 squared minus 6 times 3 plus 7. 3 squared is 9. 6 times 3 is 18 plus 7. 9 and 7 is 16. And minus 18, which is equal to negative 2. So negative 2 up to positive infinity is the range of this function. Now let's go to the last two examples. Okay, so this one is an absolute value function. So if you're not familiar with an absolute value function, if you graph this, it's going to be v-shaped. Okay, now this is negative, so which means that the v-shape is going to be like this. And all you need to do is look at that, that negative, knowing the opening of that v-shape, and then this one, because that will be part of our answer. So this starts with negative infinity up to that negative 9. Negative 9 is actually on the left side. Okay. All right, that's the y value. Okay, so which means the answer is from negative infinity up to negative 9 is the range. Okay, last example. All right, so we have here 2x minus 6. There's nothing here. You're looking for that one. This is positive, so this is a v-shaped graph, and the opening is upward. There's no k. That means it starts with 0 to positive infinity. So 0 to positive infinity. All right. So that's how you find the range of these functions: degree polynomial, quadratic function, squared function, and absolute value function. All right. So thank you for watching. I hope you learned something. You have a nice day. Bye-bye.